So what we're going to do today is we are going to review factoring. We're going to start out today with just factoring by finding a greatest common factor, and we're also going to factor by grouping today. So when we factor out a greatest common factor or a GCF, our polynomials are really just using the distributive property. So we're going to look at each monomial and we're going to look for the greatest common factor of each term. Now I know this one's already worked out. However, if we went ahead and rewrote this polynomial down here at the bottom, 6x squared y to the third plus 9xy to the fourth plus 18y to the fifth. So what I need to do is look at each term or each monomial and find the greatest common factor. Now probably back in 4th grade you learned how to find a GCF of just numbers. So we're going to use that same technique of finding a GCF between 6, 9, and 18, all of those coefficients. However, for the variable portion, we need to find what letters are in common, and it must be in common to all terms. So notice the first term has an x and a y, the middle one has an x and a y, but the last one only has a y. So the only term or the only variable in common is going to be the letter y. So then from there, to find the greatest common factor, we would look for the smallest exponent. Now, to find the GCF of the coefficients, we could either do a factor tree, we could do an organized list. A lot of you are probably really good at this and say, you know what, I don't even need to do any of that. I know my greatest common factor between 6, 9, and 18 is going to be 3. And then of the variables, they all have the y's, and I look for the smallest exponent, which is going to be y to the third. Now, what I like to do when I am factoring using the greatest common factor, I like to take that greatest common factor and write it underneath each one of my terms. Because what I'm doing when I'm factoring is I'm going to divide each term by that greatest common factor. So 3y cubed, 3y cubed. Now write it underneath. Now you don't have to show this. This is my way that I don't forget anything. Now, my factored answer will have the greatest common factor in the front, and then in the parentheses will be the answer to the division of each term. So here I'm going to divide 6 by 3 and get 2, and then I'm going to divide the variables, nothing to divide with the x squared, and then y cubed divided by y cubed is just 1. Then I'll go to the middle. 9 divided by 3 is 3. Nothing to divide into the x. And then remember, when you divide variables that have exponents, you subtract them. So here I'm left with a y. And then finally the last term, 18 divided by 3 is 6. And then y to the fifth divided by y to the third is y squared. And that would be your final factored answer. Now, one thing you can do is you could distribute this back, which was last night's homework. You could distribute it back and make sure that it did go back to your original problem. If it doesn't, then you've made a mistake somewhere. So distributing it back, it's not required, but it's highly recommended, and that would catch any mistakes maybe you might have made. Let's try the next example. All right, so again, all we're doing here on these first examples is looking for a greatest common factor and then dividing each term by it and leaving our answer in factored form. So what would be my greatest common factor between 9x to the fifth and x squared?
X squared.
Beautiful. So I am going to divide each one of my terms by x squared. I'm going to write that GCF on the outside, and now I'm going to divide 9x to the fifth by x squared, leaving me with 9x cubed. What's x squared divided by x squared? 1. Good. A lot of people think, oh, it cancels out. But anything divided by itself is 1. Now, if I were to go back and want to double check my answer, I could distribute this, and it will go back to 9x to the 5th plus x squared. Again, you don't need to show the distributing back. Your final answer here is in red. Good on that? All right. Let's try another one. Let's look at each one of the 3 terms of this polynomial. What is going to be my GCF between the 3 terms? What numbers in common between 6, 8, and 12? 2. Now, 24 would be a least common multiple, but 2 is the greatest common factor. Factors are the ways that you would multiply to get to those numbers. Now, what variable do they have in common? They all have the letter t. And the lowest exponent is just the t because they all have just the plain t. Now I'm going to divide each one by that GCF. So 6x squared t divided by 2t leaves me with 3x squared. 8xt divided by 2t leaves me with 4x. And then 12t divided by 2t is just 6. And I'm done. And again, you can always distribute it back. Now, whenever my terms, if they're all negative, I'm going to factor out a negative GCF. So for this one, what is my GCF between -3 and -18? What's the GCF between 3 and 18? It's going to be 3, right? Okay, but in this case, because they're both negative, I'm going to pull out a -3. Notice they both have a z and they both have a w. So again, I'm going to look for the smallest exponent on the z, which is z squared, and the smallest exponent on the w, which is w squared. So z squared, w squared. So now I'm going to go ahead, divide, and then I'm left with z cubed for the first term plus 6w squared. So each time negative divided by a negative is a positive. Let's try the next example. I need to find the greatest common factor between 28, 7, and 35. So again, they're not all negative, so I'm just going to pull out a positive GCF, and that positive GCF is going to be 7. Now I'm going to go through and check to see what letters they have in common. Notice all 3 terms have both an R and an S. So I'm going to go through and look for the smallest R exponent, which is r to the 3rd. And then the smallest s exponent, it comes from the middle term, it's just an s. And again, be careful, make sure your s's don't look like 5s. All right, so r to the 3rd, s. Now that I found my greatest common factor, now I will divide each of the terms by it. So the first term, 28 divided by 7 is 4. R to the 4th divided by r cubed is just r. And s squared divided by s is s. Then the middle term, I'm just dividing 7r cubed s by itself. So I need to show plus 1. And then here, negative 35 divided by 7 is going to be negative 5 r s squared. And again, you can always distribute it back. It should go back to the original problem. Pretty good? Let's try another example. Now, this one's a little tricky. All of the GCFs we found before were monomials. What's the GCF here? What do they both have in common? Y minus 2. Good. Okay, the GCF can be a binomial. So my GCF here is the y minus 2. So I'm going to divide both of the terms by y minus 2. Now notice on the first term when I divide it, I'm left with a 4 and a y minus 2. The second term, I'm just left with the 3. Now, in that bracket there, I need to distribute and combine my like terms to get my final factored answer. So I'm going to distribute the 4 to the y and to the negative 2. And then plus 3. And now I need to combine the negative 8 and the 3. So y minus 2 and 4y minus 5. So your greatest common factor can be a binomial. Now, I am going to show you another method to do this problem. It's called U substitution. So just be aware that you don't have to show this. It's just another technique that you can do. So in order to use U substitution, what I'm going to do is I'm going to let U, picking my just a variable, and it's going to represent y minus 2. So now what I'm going to do is every place that I see y minus 2 in the original problem, I'm going to put the letter U. So now I get 4u squared plus 3u. So by doing this U substitution, it makes the problem a little bit easier. So now what I'm going to do is find a GCF of this blue, and my GCF is the letter U. So then I'm left with 4u plus 3. And now that I factored it, now I'm going to take what u equaled and plug it back in. So u represented y minus 2. So now every place I see the letter u, I'm going to put in y minus 2. So I'll put a y minus 2 here for this u. And then in the parentheses, put the 4 there. And then I'm taking out u, putting in y minus 2 again. And now I'll distribute just like I did on the other side. So this stays. And then I'm going to distribute the 4. And then again combine the 8 and the 3. And now it's factored. One more factoring a GCF. So again, here, notice both of my terms are negative. So my GCF will be a negative number. So I'm going to find the GCF between 16 and 24. And that'll be 8. But I'm actually going to pull out a negative 8. Notice they both have an x and a y. So I find the smallest x and the smallest y between the two. Write the GCF on the outside, and now divide. So negative 16 divided by negative 8 is positive 2. The variables are all the same, so they're gone. And then negative 24 divided by negative 8 is 3. And then x to the 4th divided by x to the 3rd is x. X to the 3rd divided by, y to the 3rd divided by y is y squared. And it's factored. Now, at any point, whenever we do any of these factoring questions, remember, you should always look for a GCF. After you factor the GCF, if what remains in that parentheses could still be factored more, you keep going. Now, tomorrow we're going to learn the difference of two squares, and you'll pull out a GCF sometimes first, and then you'll factor the difference of squares. Or maybe what's left behind is a trinomial that could be factored. So always, whenever you're factoring, look for the GCF first, and then from there, use one of the other techniques that are going to be up and coming that we're going to review. The next thing we're going to review is factor by grouping. So we would use factor by grouping when we don't have a binomial or a trinomial, maybe a 4-term polynomial. And we couldn't factor it any other way except for by putting it into groups of 2. So, for example, this is my original problem. And as it sits, I can't find a GCF. I should always look for a GCF first. But if you notice, between the 4 terms, there's nothing in common for all 4. However, if I decide to take them 2 at a time and make a group here and a group here, then by itself, this group has a greatest common factor of the letter A. And then this group, when I make it, has a GCF, or a greatest common factor, of 6. So when you factor by grouping, you're going to turn a 4-term polynomial into 2 separate groups. And you will find a different GCF for each group. So this one is the letter A. Again, you write the GCF outside, and then you'll divide, and you get x plus y. Over here, my GCF is 6. And again, divide, and x plus y. When you factor by grouping, the answer you get after you divide, this right here, must be the same for both groups. If it's not, you've either pulled out the wrong GCF or you just can't factor by grouping. Once you divide and you get the same thing in this parenthesis, that's now becoming a GCF. You write it once, and then you take the 2 things that you just divided by, these 2 GCFs, and it goes in the other parentheses. Keep in mind, it doesn't matter if you write the a plus 6 first or the x plus y first. Either way. The next one again, I'm going to leave it in the same order. Sometimes you got to rearrange the terms, but both of these examples, we could have left it alone. So I'm going to, again, group the first 2 and group the last 2. Again, I'm looking for a GCF of the first 2, which this one is the letter M. Once I divide, I'm left with p squared plus 7. And then over here, my greatest common factor is going to be 3. Again, write the GCF and then divide. Again, your goal is to have these things turn into exactly the same, which it is. You write it once, then you take the 2 GCFs that you just divided by. Again, remember, we can FOIL this answer, and it needs to go back to the beginning. So you can either FOIL or distribute. If it does not go back to the beginning problem, you've done something wrong. Okay, let's try one without all the work on it. So again, this one, the way it sits, we can factor it. Now, if you want to rearrange, you can, but I'm going to factor it the way it is. So I'm going to make a group of the first 2 and then a group from the last 2. what is my greatest common factor of 10ab and 6b? 2b, I heard somebody say. So I'll divide both of these by 2b. 10ab divided by 2b is 5a, and 6b divided by 2 is 3. Then the second group, my GCF, is going to be 7. Again, divide. And again, if this division, this number in the parentheses, this binomial, if it is not the same, you got to go back and double check your GCF. Or maybe it can't even be factored. So now, once you've factored out the separate GCF from both, write the one that's in common, so the 5a minus 3, and then take the 2 that you just wrote outside. 2b plus 7. Good so far? All right, let's try the next one. Now, at first glance, if I try to group this one, is there anything in common? No, right? So I need to rearrange it. Now, I could just flip-flop these two, and it probably will make my problem a little bit easier. I'm going to make it a little challenging. I'm going to pull this one and put it up here. So instead, I'm going to do 2y squared. I'm going to pull that last term right next to it, then the az, and then the 2z. Again, it doesn't matter. There's more than one way to do these. So I'm going to do it this way. Group here, group here. All right, so now, what is my greatest common factor of my first group? Y squared, right? So divide both of them by y squared. This becomes 2 minus a. Now, what do you think the GCF of the second group is?
Z.
Okay, let's watch what happens when we divide by z. When I divide by a positive z, I get a minus 2. Does that look like the other one?
No.
No. What could I do to make it look the same? What could I pull out instead? Beautiful. Now, some books would teach you at this point to pull out a -1 GCF, but I like to just say, you know what? As soon as I see it's wrong, I'm going to change the sign on my GCF to see if that makes things better. And it does. It's still not written right. I'm going to flip it around. So notice over here, it's a -a, and it's a -a here, and a +2. I'm just going to flip it around now, and so it'll look identical. So y squared, I'll leave this one, and I'm just going to flip this one around and do 2 minus a. Now the two parentheses look the same. So 2 minus a, and then y squared minus z. And again, you can multiply it back to make sure that you did it appropriately. Two more examples and we're done. Let's try another one. Pretty good? All right. This one, it's good the way it's written. So I'm going to go ahead and make my groups. My GCF of my first group is going to be 2x squared. After I divide, I get 2x plus 1. Now, what can I pull out for a GCF of the second group? So it makes it look the same.
Negative 1.
Beautiful. I'm going to pull a negative 1 out. And then I get 2x plus 1. Because again, remember, your goal is to make these the same. Okay? So you can always pull out a 1 GCF sometimes or a negative 1 to make it work. So again, write that thing that was the same, the 2x plus 1, and then again, the 2 GCFs. And you're done. Now, if this one right here, this blue, maybe looked like, and this is what we're going to learn tomorrow, if it looked like 4x minus 1, this is the difference of two squares, and we would keep going. However, it's not the difference of two squares, so we're finished. So we're going to stop right here, and my final answer is in the box. One more example. Again, I'm going to keep it in the same order. And I'm looking for a greatest common factor of my first group, and that's going to be 5. So 15 divided by 5 is 3. And then this becomes m squared. Hi.
Hi.
All right, so my greatest common factor of this second group, what do you think it's going to be?
R squared.
Okay. Positive or negative?
Well, I need positive, yeah.
You think positive?
Well, negative, I guess, yeah.
Good, negative. All right, so then I get positive 3 minus m squared. Nice. So then you'll take the 1 in common and then the 2 things that are outside of the parentheses. And you're done. So that is factoring with the GCF and factor by grouping. Tomorrow again will be the difference of two squares and the sum and difference of cubes. So your homework is page 43, and it's 1 through 21 odd. Any questions? All right, excellent.